Volcanoes that slept for centuries are now shifting beneath British Columbia, and scientists have proof. Ground at Meager is rising by millimeters. Garibaldi's heat plume glows in satellite scans, and Franklin's glaciers are melting faster than ever. New data connects these peaks into a single magmatic corridor, and if just one erupts, entire valleys or even Vancouver's skyline could change forever. But the signals raise a question no one expected. Will we see disaster coming in time? Or is Canada's silence about to be shattered? Mount Meager, northwest of Pemberton, is sending unmistakable signals from beneath its rugged slopes. Since March 2023, satellite radar called INSAR has tracked the ground on Meager's southwest flank rising by 12 millimeters, a change that volcanologists at Natural Resources Canada flagged as outside the usual background motion. This uplift is not a seasonal swelling or the slow rebound of glaciers. It traces a curve that steepened sharply in early 2023, matching patterns seen at volcanoes where magma pushes upward through the crust. At the same time, remote gas sensors on the mountain recorded a spike in carbon dioxide and sulfur dioxide ratios, classic chemical fingerprints of magma moving closer to the surface. Natural Resources. Canada's internal logs show field teams coordinating rapid reviews as these numbers climbed, with every new data point adding urgency. For a volcano that last erupted over 2 millennia ago, this combination of rising ground and magmatic gas is a direct physical message from below. It's the first pillar in a growing case that Meager, long considered dormant, is anything but silent. Mount Garibaldi, standing sentinel above the sea-to-sky corridor, has drawn new attention from volcanologists, not for any visible eruption, but for a patch of unexplained warmth. In late 2023, Sentinel-2 satellite imagery captured a persistent thermal anomaly on Garibaldi's southern flank. The heat signature, distinct from wildfires or seasonal snowmelt, spanned nearly half a square kilometer and lingered for weeks. Technicians at the Geological Survey of Canada flagged the anomaly, cross-checking for surface disruptions, and found none. In the pre-dawn hours of September 18th, the sea-to-sky seismic network recorded a short burst of harmonic tremor beneath Garibaldi, a low-frequency vibration often linked to fluid movement deep underground. Automated thresholds triggered a yellow alert at 3:32 a.m., pushing the team into a rapid review cycle. By midday, with no further escalation, the alert was downgraded. Still, the combination of a stubborn heat patch and a fleeting tremor stood out. Garibaldi's unrest appeared independent, yet its timing paralleled signals seen at Meager, strengthening the idea that these dormant volcanoes might not be acting alone. Franklin Glacier, tucked beneath heavy ice in northern British Columbia, is now drawing urgent attention from glaciologists. Since early 2022, radar cross-sections have tracked a sharp rise in melt rates at the glacier's base, over 30% above the average seen in previous years. Subglacial temperature loggers, drilled through nearly 1 kilometer of ice, reveal pockets where the core temperature is climbing faster than expected. The data point to a concentrated zone of melting directly above a suspected magmatic conduit, far deeper than seasonal thaw can explain. This is not just surface runoff. It is a hidden, accelerating loss of ice at the glacier's heart. Field teams note that the thinning is most pronounced near the old volcanic vent, where radar returns show ice layers sagging and deforming over a widening cavity. For scientists, these patterns signal more than just climate-driven melt. They raise the specter of sudden instability. If the glacier's core collapses, the resulting flood could sweep debris and water down valley in a matter of hours. With Franklin's melt rates breaking records, the risk of a lahar, an ice and ash-choked torrent, can no longer be dismissed as remote. Beneath the peaks of British Columbia, a debate is unfolding that cuts to the heart of volcanic science. Some researchers see the recent signals, uplift at Meager, heat at Garibaldi, melt at Franklin Glacier, as fragments of a single deeper story. Magnetotelluric surveys and seismic tomography have mapped a broad swath of low-resistivity rock stretching from Meager to Garibaldi, buried between 10 and 25 kilometers down. The anomaly runs for nearly 200 kilometers, with electrical resistivity readings dropping below 10 ohm meters, far lower than the surrounding crust. Seismic models echo this, showing a corridor of slower wave speeds, hinting at partial melt threading through the region. For advocates of the corridor hypothesis, these numbers suggest a vast interconnected magmatic system capable of cascading eruptions if the right trigger comes along. Yet not everyone is convinced. Geochemists point to helium isotope ratios sampled at springs and vents along the same transect. At Meager and Garibaldi, the values hover between 0.2 and 0.5 Ra, distinctly crustal with no sign of fresh mantle input. North of Meager, near Franklin Glacier, the ratios jump to over 1.0 Ra. The break is sharp and the error bars are tight, plus or minus 0.05 Ra. If a single corridor truly linked these volcanoes, the isotope signatures would be expected to blend, not fracture. Instead, the chemical data draw a line in the crust, separating north from south. The rift between physical and chemical evidence keeps the scientific split alive. Some volcanologists argue the geophysical corridor is a red herring, an artifact of fluids not melt. Others insist the isotope break is a surface effect, missing deep connections. For now, the corridor remains a hypothesis, not a certainty. The only consensus is that the stakes for getting it right are enormous. A collapse at Mount Meager would not be a distant spectacle. It would be measured in meters of debris swallowing entire stretches of the Pemberton Valley. Hazard models show that a full flank failure could bury up to 3 kilometers of river corridor beneath more than 100 meters of rock and ash. Emergency planners in the Squamish-Lillooet district keep updated maps on hand, tracing evacuation routes that cross bridges and hydro lines, each one at risk of being severed for weeks. For the Lilwat Nation, these scenarios are not theoretical. Elders recall stories of the Fire Mountain, accounts of lands that vanished overnight, woven into school drills and band office protocols. If Mount Garibaldi were to erupt, the threat would drift far beyond its slopes. Atmospheric models forecast ash plumes sweeping toward Greater Vancouver, with PM 2.5 concentrations surging above 100 micrograms per cubic meter. That is enough to close airports, contaminate reservoirs, and send hospital admissions spiking for respiratory distress. Whistler's emergency managers have drafted plans to keep ash out of schools and airports, but no one can guarantee clean air when the wind shifts. Franklin Glacier holds its own danger beneath the ice. Should the volcanic core destabilize, rapid melt could unleash a lahar, a thick debris-choked flood racing down the Burke River Valley at highway speeds. Pathway maps show swaths up to a kilometer wide, threatening remote settlements and infrastructure with little warning. University of British Columbia scientists warn that current mapping is incomplete, and local indigenous leaders press for their knowledge to be included in evacuation planning. For every community in the shadow of these peaks, the hazards are precise, mapped, and personal. Across the sea-to-sky corridor, the warning system for volcanic unrest is stretched thin. 7 seismic stations are spread over more than 10,000 square kilometers, leaving wide gaps where tremors or ground shifts might go undetected for hours. Only 2 active gas sensors scan for surges in sulfur dioxide and carbon dioxide, and together they cover less than 1/3 of the most at-risk zones. Satellite radar, the backbone of ground deformation tracking, revisits each peak every 6 to 14 days. That means a crucial uplift or collapse could unfold and pass before the next dataset arrives. Monitoring officials at Natural Resources Canada review every alert, but with so few eyes on the ground and in the air, the window to catch the earliest warning signs is dangerously narrow. A sudden burst of tremor or a gas spike could leave emergency planners with little more than minutes to react. Warning times in volcanic crises are measured in minutes, hours, or if we're lucky, days. For sudden landslides or explosive blasts, the best-case window might be just 10 to 30 minutes. Magmatic intrusion, tracked through seismic and satellite data, can offer a few days' notice, but only if the network is dense and continuous. Experts recommend adding 5 broadband seismic stations across the corridor, paired with a full array of sulfur dioxide sensors to cover every high-risk zone. The projected cost for a modern integrated system is 3 to 4 million Canadian dollars, enough to close the blind spots and shrink data delays. Indigenous partners, including Lilwat and Squamish nations, are central to this roadmap, combining traditional knowledge with real-time alerts and evacuation planning. With these upgrades, British Columbia could move from reactive warnings to proactive safety, giving communities the time they need to act. Today, satellites track every tremor, but volcanic corridors do not honor borders or timetables. British Columbia's fate hinges on minutes of warning or none at all. In a world where nature's timelines outpace our own, the next eruption is not a distant threat. It is a present, silent countdown.